Assalamu alaikum. My name is الهنوف and today we will talk about longitudinal stress and pressure veils, focusing on Ras Lafan industrial area. What are pressure veils? Pressure veils are containers specifically designed to hold gases or liquids at pressure substantially different from absolute pressure. These critical components are initially in industries such as gas processing and petrochemical manufacturing. In facilities like Ras Lafan Industrial City, pressure veils play an important role in safely storing and processing natural gases and petroleum products under extreme conditions. Ras Lafan Industrial Cities is one of the world's largest industrial hubs of liquid natural gases, LNG processing. The facilities rely on pressure veils for gases separation, storage, and processing operations. Industrial safety is paramount at Ras Lafan. Proper stress analysis of pressure veils ensure safety operations, prevents catastrophic failures, and protects workers and the environment. Understanding internal pressure. Internal pressure push outward on the veil's wall in all directions. These pressures is created by gases or liquid storage under high pressure inside these veils. Understanding internal pressure is external for stress analysis and ensuring veils safety in industrial applications like those at Ras Lafan. Effects of internal pressure on veils. Internal pressures on veils can reach thousands of kilopascal pressure, causing stress that can lead to failure if not properly managed. Understanding these forces is critical for safety veils design and operation. There are two types of stress and pressure veils. The first one is longitudinal stress, acts along the length of the veils parallel to the cylindrical axis, causes by internal pressure pushing against the veils and caps, critical near vessels and support and connection points. The second one is hoop stress, acts around the surrounding of the veils perpendicularly to the axis. The resist the outward force and interior pressure on the cylindric walls, typically about twice the magnitude of the longitudinal stress. Why the difference? Longitude and stress and hoop stress. Hoop stress is typically about twice the longitudinal stress in the cylindrical pressure veils. This significant difference directly influence critical designs to decide particularly walls thickness specifications. Different stress magnitudes require different safety constructions. Wall thickness must communicate the higher hoop stress. Longitudinal stress becomes critical near valves and supports and weld joint, where stress concentrate occur. Pressure valves and operations. Hoop stress zone acts conformations around these vessels wall perpendicular to the vessel's axis. This stress is typically twice the magnitude of longitudinal stress, and this is primarily designed to consideration of the wall thickness. Longitudinal stress zone acts along the length of the vessel parallel to its axis, critical at vessel's end, near support and at weld seams. Both stress must be carefully managed for safe operations. Thin-walled pressure associations. A pressure vessel is considered thin-walled when the wall thickness is less than 1/10 of the vessel radius. This important association allows engineers to treat stress as uniform across the wall thickness. This simplification greatly reduces calculations complexity while managing according for most industrial application. At Lafan, many cylindric storage vessels meet this criteria. Straightforward stress analysis. Eliminations of thin-walled vessels. A thin-walled pressure vase has wall thickness T less than 1/10 of its radius. This diagram shows the key dimensions and the stress directions acts on the vessel's wall. The key label elements: radius from center to inner wall, wall thickness, longitudinal stress along vessel length, and hoop stress around the surrounding. Formula of longitudinal stress. This formula calculates the strength acting along the length of the cylindrical pressure vessel. These factors of 2 in the denominator reflects how pressure force distribute across the vessel initial area. Formula of hoop stress. Hoop stress is approximately twice the longitudinal stress. This relationship drives the criteria decide for vessel's wall thickness. Example calculations: longitudinal stress. Giving data: internal pressure is equal to 2 megapascal, radius is 0.5 meters, wall thickness is 0.01 meter. In the results, the longitudinal stress is 50 megapascal. Now, calculating hoop stress. Giving data 2 megapascal for the interior pressure, for the radius is 0.5 meter, and the wall thickness is 0.01. As you can see, hoop stress is 100 megapascal, is exactly twice the longitudinal stress. Now, try it yourself. Now we will compare by this chart. This chart compares the calculated stress from our work example. Longitudinal stress is 50 megapascal, while the hoop stress is 100 megapascal. The hoop stress is exactly twice the longitudinal stress, confirming the theoretical relationship between these two stress types in wall and thin wall pressure veils. Design and safety applications. Material selection. Material choices developed on maximum stress levels. Since hoop stress is roughly twice longitudinal stress, material must withstand the high forces. Wall thickness design. Engineers calculate minimum wall thickness based on the hoop stress to ensure vessel's integrity. In specifications focus high stress area required regular monitoring and prevents catastrophic failures. Lafan applications example. Pressure vessels are initial components in Lafan. Gas processing facilities. These vessels operate under extreme handling liquid natural gases and another high pressure fluids critical to cutter energy productions. Accurate stress calculations ensure safety operations and maintenance of these industrial area. Engineers regularly verify that longitudinal and hoop stress remain within design limits, protecting workers and industrial cities. In the summary, pressure vessels hold high pressure fluid safely. Interpressures cause longitudinal and hoop stress. Hoop stress is about twice longitudinal stress. Thin walls simulations simplify stress analysis. Accurate stress calculation critical for safety. Material selection and wall thickness developed on maximum stress. Any questions? Thank you for hearing us.